Hi everyone, we're going to sketch the region enclosed by the curves and lines and integrate with respect to x. Also find the area of the region. So let's see where there's any intersections. Let's first look at these two. We have y equals 1 divided by x. We have y equals y. So we can set 1 divided by x equals x. That gives us x squared equals 1. So we have x equals plus or minus 1. But our x has to be positive. So we're just going to take x equals 1. All right, so we have that point here. If x is 1, then y is 1. So we have that one. And we also have 1 divided by x equals 1/4 x. So that's going to give you 4 equals x squared. So we have x is plus or minus 2. Again, we want our x to be positive, so our x is just going to be 2. Now for this one, if x is 2, then y is going to be 1/2. And we're doing that so we can help graph these. So let's go ahead and graph them all. So we have one intersection point at 1, 1. Let's make this 1 and 1. So right here, and we also have one at 2 and 1/2. So we'll have 2, 1/2 is about there. So let's just put that there. Now let's graph some of these. So I'll use green for the, let me do this. This one is first. So y equals x. So that's just going to look like this. Remember, we want x to be positive. So we're only looking at this first quadrant here. So I'm going to look at, just start right about here. And there is y equals x. All right, and then y equals 1/4 x. That's the one we did the second one, and that one's going to go this way. And then we have y equals 1 divided by x. That's going to go through 1. I'll do that one in yellow. And remember, that one is just going to look like this. And it's going to go through this here as well. Anyway, there's your sketch. The area that we want to look at is this right in here. So the way to set it up is we're going to look at, since we had to do all of this with the comparisons, our area is going to equal the integral from 0 to 1, and that's going to be this piece right in here. We're splitting this up. So, because we have this intersection point. All right, and since we're looking at this area, our upper bound of the enclosed area is y equals x. So you're going to write x minus the lower bound is the red. The red is this one. So you're going to minus 1/4 x. All right, and then we do dx. And then we're going to add the other area, and that's going to be from 1 to 2. Now, the upper bound, that's one you put first, is the yellow. That the upper bound encloses the shaded region. That is 1 divided by x. The lower bound is the red again. So that one is going to be minus 1/4 x dx. So we got that all squeezed in there. And now let's simplify this. This is going to equal the integral from 0 to 1. This is just going to be 3/4 x dx. And this one's still going to be the same. 1 to 2. 1 divided by x minus 1/4 x dx. I'm going to integrate here, and then I'm going to move to another slide, so you might want to copy it down. For this piece, this is going to be 3/8 x squared from 0 to 1, plus this piece is going to be ln of x, absolute value of x, minus 1/8 x squared, and we're evaluating this from 1 to 2. All right, so I'm going to go ahead and substitute all this in. I'm going to go ahead and copy it down again, so we're running out of room. So I'll do this really fast. We had 3/8 x squared, 0 to 1, plus ln of absolute value of x minus 1/8 x squared from 1 to 2. All right, so for this piece, you're just going to get 3/8 and then minus 0, so we don't have to worry about that. For this piece, we're going to get plus ln of 2 minus 1/2, and then we're going to have minus, you substitute in 1, ln of 1 is just 0, and then we're going to have minus 1/8. All right, let's see what all this is. This is all going to equal, we have 3/8 minus 1/2 plus 1/8. All right, let's see what this is. This is going to be 4/8. So this right here is going to be 1/2. 1/2 minus 1/2 equals 0. So all we're left with is ln of 2. So ln of 2 is your area of the region. And that's it. Thank you. Have a nice day. Bye-bye.